In this video, we're going to be looking at Standard 4 in SBT 5. We are going to be multiplying a 4-digit number by a 1-digit number, and also a 2-digit number by a 2-digit number, using strategies based on the properties of operations to illustrate and explain the calculation by using rectangular arrays, area models, and/or equations. By the end of this video, you should be able to use standard algorithm to multiply. You should also be able to multiply up to a 4-digit number by a 1-digit number. We are going to start by trying to get our math brains going. So if we look at the question, it says which two numbers are closest? And then how do you know? So looking at the three numbers in the circles, which two numbers are going to be the closest, and then explain how you know. You have 40 seconds to solve this. Alright, so in order to figure out which two numbers are the closest, we are going to need to find the difference between them, which means we are going to have to subtract. So I'm going to start with these two numbers here, 15 and 35. So I would do 35 minus 15. I know that 5 minus 5 is 0, 3 minus 1 is 2, to give me 20. The difference between 35 and 15 is 20. Then I'm going to look at the difference between 35 and 23. Starting with 5 minus 3, which is 2. 3 minus 2, which is 1. The difference between 35 and 23 is 12. Finally, I look at my last set of numbers, 23 and 15. I start by doing 3 minus 5. This is not possible, so I borrow from the 2, which becomes a 1. The 3 becomes 13. 13 minus 5 makes 8. 1 minus 1 makes 0. So the difference between 23 and 15 is 8. When we are looking for the numbers that are closest, that means the one that has the smallest difference, which is going to be 15 and 23. Using standard algorithm, we are going to solve 264 times 3. Before we start, we need to review place value. The purple column represents the ones place. The green column represents the tens place, and the blue column represents the hundreds place. So that tells me that the 4 is in the ones place, the 6 is in the tens place, and then the 2 is in the hundreds place. When we go to multiply, we are going to start by looking at the ones place, and we're going to take 3 and we're going to multiply it by 4. Now, I know that 3 times 4 is 12. So that 2 goes on the bottom, the 1 goes atop the tens place. Then I move to the next column, which is the tens place. I'm going to do 3 times 6. I know that 3 times 6 is 18, plus the 1 at the top, which makes 19. So the 9 goes at the bottom, the 1 goes at the top. Finally, I look at my hundreds place, and I'm going to do 3 times 2. I know that 3 times 2 is equal to 6, plus the 1 at the top, which makes 7. This gives me a product of 792. If we look at another example, we're going to start by reviewing our place value. The purple represents your ones place. The green represents your tens place. The blue represents your hundreds place. So again, what we're going to do is we're going to start in our ones place, and we're going to do 9 times 7. 9 times 7 gives me 63. The 3 goes on the bottom. The 6 goes on the top. Then we're going to do the tens place. And we're going to focus on 9 times 6. 9 times 6 is 54, plus the 6 that's on the top, which would give me 60. So we would put a 0 on the bottom and a 6 on the top. Finally, we look at the hundreds place by doing 9 times 4, which we know is 36, plus the 6 that is here, which is going to give me 42. So at this point, I would write 42 at the bottom. Adding my comma, this gives me 4,203. So the product of 467 times 9 is 4,203. Now, let's focus on a brain break. So let's talk about some vocabulary. Factors and products. The product is going to be the answer, or 228. So we call the answer the product. The factors in this problem are 54 and 7. What do you think would be a good definition for factors? So a good definition for factors, if factors are the 54 and the 7, we could say that factors are two numbers that we multiply together. So again, your factors are the two numbers that we multiply together. Your product is going to be your answer. Now let's look at a joke. So here we have a 7 and a 3 walking away, and then we have a 6 and a 2 standing outside their house. It says, boy oh boy, good old 7 was in prime form tonight. I guess they just strike me as such an odd couple. Think about this joke for a minute and focus on this word, odd. What do you know about that word, odd? Alright, so thinking about that word odd, 7 and 3 are both examples of odd numbers. But there are some other odd numbers that go along with it. What are the other odd digits that we know of? That's correct. 1 is an odd digit. 5 is also an odd digit, and 9. So whenever you see these digits in the ones place, that is going to make a number odd. So now we are going to continue to use standard algorithm to solve multiplication problems. Here we have 2,349 times 8. Well, again, we know that the purple color represents the ones place, the green represents the tens place, the blue represents the hundreds place. What place is represented by the yellow? Correct, that is the thousands place. So we're going to follow the same steps, and we're going to start by multiplying 8 times 9. Now, we know that 8 times 9 is 72. So we're going to take the 2 and put that on bottom. The 7 is going to go on top. Then we're going to do the tens place. 8 times 4. 8 times 4 is 32 plus the 7 that's at the top. So 32 plus 7 gives us 39. The 9 would go at the bottom. The 3 would go at the top. Then we're going to move to our hundreds place, and we're going to do 8 times 3. 8 times 3 is 24 plus the 3 at the top, which would give me 27. 7 goes on bottom, 2 goes on top. Finally, we go to the thousands place, where we're going to multiply 8 times 2. 8 times 2 gives me 16, plus the 2 at the very top, which is going to give me 18. So we put the 8 in the thousands place and the 1 next to it. This gives me a product of 18,792. If we look at one more example, we have 2,045 times 6. Again, starting with our place value, the purple represents exactly the ones place. The green represents the perfect tens place. The blue represents the hundreds place, and the yellow represents the thousands place. So what we're going to do is we're going to start in our ones place, and we're going to multiply 6 times 5. 6 times 5 gives me 30. So we put our 0 at the bottom, we put our 3 at the top. Then we move to our tens place. That gives me 6 times 4. 6 times 4 is 24, plus 3 more would give me 27. 7 on the bottom, 2 on the top. Then we move to our hundreds place, which gives me 6 times 0. Anything times 0 is always 0, but we can't forget the 2 at the top. So 0 plus 2 makes 2. We're going to finish up in our thousands place by doing 6 times 2, which is going to give me 12. The 2 goes in the thousands place, the 1 goes next to it. So the product of 2,045 times 6 is 12,270. Using what we've talked about today with standard algorithm, see if you can finish this problem. You have 1 minute to see if you can finish the problem using standard algorithm. Alright, if we look here at this problem, we start in our ones place where they multiplied 6 times 7. 6 times 7 gave them 42. They put the 2 at the bottom. They carried their 4 to the top. Then they moved to their tens place where they did 7 times 8. 7 times 8 makes 56. Plus the 4 that's on the top, which would be 57, 58, 59, 60. So they put the 0 on the bottom, they put the 6 on the top. Then they moved to their hundreds place and multiplied 7 times 5. 7 times 5 is 35, plus the 6 at the top. 36, 37, 38, 39, 40, 41. So we put a 1 on the bottom, and we put a 4 on the top. And to make sure we're correct, we finish it out by doing 7 times 2. 7 times 2 gives us 14, plus the 4 at the top, which would be 15, 16, 17, 18. That tells us that 2,586 times 7 is equal to 18,102. Now you are going to complete a review task. So you are going to be presented with an activity that has a problem set up for you, such as 556 times 3. You are responsible for going through and filling in each question mark with the correct value.